Hello everybody, welcome to the session of Bitbucket. So before going to the Bitbucket session, we will be covering some Git part, which is a version control system, or we can say the Git is a version control tool. So we will start for the Git tutorial. We will be covering in this session these points: version control, why we require that in our project or organization, and what is the version control system. After that, types of the version control system. We are considering or learning the Git version control system. So installation of that. Uh, we will be covering installation on the Windows and Linux both. After that, Git workflow. It is Git is having their specific workflow. So we will be learning that too. After that, Git operations and commands, and at the last, hands-on to the commands, which we will be going through this PPT. So let us start for the version control system. What is that and why we should use the version control system? So version control system is a tool that helps project team to manage the changes in the source code. So what this means, consider a scenario, you are working with a client. So there are 2-3 developers who are working with the client. So client give you a requirement on first day. Client gave you a requirement, suppose for the login page. You develop that code, and one developer developed that code, and you were successfully created the login page. You shown that to the client. But after that, your client says, no, I want this functionality, like likewise other way, or some other requirement. So you changes that code, you saved on your desktop, you changes that code, and after that you shown that you changed functionality to the client. Okay. After that, client changes their requirement. He says, oh no, that is not required, or we changed our requirement to the previous one. What you showed previously in the first demo, that was right, and we want that only. So you revert back to that functionality. So this is a problem, because that developer saved the code to the local desktop. So he can't revert back to the previous code, because that code was deleted by him or her. So what should we do this? What is the solution for this? So this can be handled by the version control system, because this maintains your version by version code changes, and also the code conflict that might be, we can say, that might be from the other developers. Here we consider a scenario like one developer committed the changes for the login.php or login.html. Other developer on the same day or other day changes that file, mm, changes that file and saved. So how we track the changes done by the both developers? So this is handled with the version control system. There are many advantages, and this is a main tool, we can say, when we start the implementation, or when we start the project. So when we start the coding, we must consider a version control tool. Anything like here given is the Git, SVN, Mercurial, Perforce, etc. We can consider or we can use any one of them, but as we go, we will see the difference between Git, SVN, and what is the better option to implement or to use in our project. So I think you got a better idea what is a version control system and why we use this. After that, there are two types of version control system. One is centralized version control system and one is distributed version control system. We will see the difference in between both, but From the difference of both, we will get to know what is the better and what to use in our project. Example for the centralized we can version control system can be, we can say in short form as VCS. So centralized VCS, we can say example is SVN, and for DVCS example is a Git. So centralized version control system, as you can say, working copy is our, we can say, is our workstation or our PC or our local desktop or local laptop where we do the coding. After coding, and here we see the server repository. Okay, so in server repository, here, the server repository is centralized repository from which everyone access the code and saved this copy to the local workstation or local PC is a working copy. So suppose there are these three developers who are working on a one project and developing their code on individual workstations. Yes. So after user 1 or developer 1 done the code, developer 2 done the code, developer 3 also done the code, what is the next action after completed the code is to commit, uh, to to commit the changes or the new files to the repository which is located in the server or remotely somewhere. So the disadvantages of this is centralized version control system is three developers are dependent on this central repository. This is the remote repository. Yes, because when it goes down, so these three developers will be idle and will be doing nothing because they don't have the latest copy of the central server repository, or we can say the code. So this is the main disadvantage when we consider the central version control system for our project, and we also can um, see the versions maintained as per as compared to the distributed version control system, which will be seeing later in the Git. This is the main disadvantage. Please keep this in mind. The difference between central and distributed is, in central the developers are dependent on the remote repository. So after that, next, distributed version control system. So distribute, as we see, the distributed version control system example is Git. So here are, you can see the one stage is added like repository. From the previous one, we can say that this one stage is added here is a repository. So again, there are three developers working on a project who are using the code and creating a files, editing it, etc. So after that, in centralized version control system, what was there, like they are committing or the updating server repository. Yes, but
This conference will now be recorded.
so here one stage is added is repository. This is the between layer. So what does this mean? When we check out or clone a local copy from a remote server or remote repository, so in between this is a Git. We can say that example of the distributed version control system is Git. Using Git, we pull or check out the code in our local working directory. So our dependency is only here in this layer. not here as in the centralized version control system. So here is the no disadvantage, like we are dependent on the central server. If this goes down, so developer are not dependent on this, so they can start work with this layer or this repository. So it will be clear in the next slide. So here we consider between layer of repository as a Git and the remote repository as a Bitbucket repository. So the developers will be committing code to the local, that is a Git, and after that, after everything goes well, after that they commit their changes to the remote repository, that is a Bitbucket. For this demo, we have considered the Bitbucket. There are multiple options like GitHub, code commit from AWS. So here we are considering or learning the Bitbucket. Okay. So here are the multiple advantages of distributed version control system over the centralized version control system. So first of all, as I told you, first one is we are not dependent, or the developers are not dependent on the remote repository. Second, if consider a scenario like all developers have worked yesterday, last developer committed the code to the remote repository yesterday, and again today one developer wants to modify the last committed file for the new feature. So first of all, that developer will pull the code, as this is shown here, like pull and push. So we first need to pull the changes from the remote to our local using the Git. So when we pull the changes, so it will automatically resolve our merge conflicts. Merge conflicts are we will see in detail in the next coming slides. But for the reference, merge conflicts are, suppose I have edited one file and another developer edited the same file. So which changes need to be kept in the remote repository, that must be that file must be updated, because that is a repository, say a remote repository. So when we pull the changes, it will fetch the working copy and the final copy of the code to the location. So it will resolve the merge conflict also, and after that, this is a second advantage, it will resolve the merge conflict. It third advantage is it will maintain the versions, like I have edited a file, and another time or after some time another developer edited that file. So the it will keep dvcs keep the list or logs of the commits, when and what time the developer committed, in which file he committed, how many insertion or addition happens, how many lines are deleted, what changes are there in the current commit, etc. I think you got the difference between centralized version control system and distributed version control system. So over centralized version control system, distributed version control system is a better. So we will be considering here the Git, how to implement and use the Git in our project. So installation of the Git. First of all, we will see for the installation of Git on the Linux. So, if your Linux machine is Debian, so it is a apt Git we use for the installation. Simply run two commands. First need to update our Linux using the apt Get update, and after that install Git using the apt Get install Git. Here, this command. Okay. After that, if it is a Fedora like CentOS, we can say the CentOS. So the repository manager, we can say it is a yum. So we will update our system using the yum update, and after that we will install a Git using yum install Git. we will see we will cross check it with the git version. So it will give you the latest version uh, of your install git. I have my CentOS machine, so I have followed these two steps and git is installed already installed on my system. So we can say this is my Linux machine, so we can say the git. Give me 1 minute. I will increase the font.
This conference will now be recorded.
Yes. So we can check git version with the git hyphen version command. So I will show you on my screen. Yes. So here are we in my Linux machine or Linux VM. So we can just type git hyphen version. So it will give me the version that is 2.14 on my machine. Yes. So after that, configuring username and email ID. Why this is important? So as I said, distributed version control system monitors the commits and the versions of your committed code in the repository or in the logs. So how we identify when which user done these changes? So we can configure this using the configure command. So we can configure our username and email ID. Email ID is not important, it is optional, but for the security and in the future purpose, we can configure our email also using the config global command. So we will just type the command. Write your name in double quotes. Mr. Deepika Joshi. Yes, it is done. After that, write your email ID. Yes, user.email in double quotes, give your email. Okay, done. So we have done this. After that, installation on the Windows. Same, follow these steps. Go to the link I have given. This one. Go to this link. Download the latest installer for the Git and follow just next and do the finish. It will open a command prompt or the installation is completed. Then open a command prompt. It may be a git bash or our simple Windows command prompt. So what is git bash? When we install a git on Windows, it will give you another command line which we use for the git. So it both will be work for the git commands, git bash and the Windows command line. We can use anyone. After that, as I showed you the same way, configure the username and email ID from the command prompt, then the Windows installation is done. Okay, so we learn how to install Git on Linux, both Debian and Fedora, and after that on the Windows. So after that, I said the Git is having the workflow, special workflow or the dedicated workflow for the Git. So this is a workflow. So I will explain what is it exactly. Uh, Suppose I have created a local copy of my repository and I have a copy of my code to the remote location also. So this is what what just said is this. So I have a copy of my code on the local system also, and I have a copy of code to the remote location also. So first we consider the local part. These are the stages in the local part. So working directory. This is a working directory which we just saw in the diagram, like we are having our desktop or PC or workstation, that is a working directory or working folder for the Git or our project code. So when I changes a file, suppose I have created a login file and I have done the coding for the login page for my application. So what the next step is, we just need to add that file to the staging area. Staging area is nothing but, it is not a physical entity or physical something that we can see. It is a logical area of the Git. So it is a we can say when we do the add of that my login page, we add when we add the login page, then it will go to the staging area. Okay, so how I check my login page is available on the local repository or not? If I have done only the add, then it will not reflect to the local repository. For that, I need to do is git commit. After the git commit, it will be added to the local repository. Okay, so after the git push, I need to push that changed file to the remote location. Then and then only I can see my file to the remote location, and other developer can check out or work on that file as and when required. If that file is in a local repository, so other developer can't uh, clone or pull my changed file, or can't pull my latest changes for their requirement. So that must be pushed to the remote repository. After that, other developer want the files from the remote repository to their local system. So there are two options. First of all, pull the changes from the remote to the local repository. Okay, so when we pull the code from the or files from the remote repository to the local repository, we can use the git pull command. And after this command, you can see the changed files or changed commits or latest version of your code to the local repository. So if you want to work on the exit file, exit exit or we can say the logout file, so we can use that file with the checkout checkout to the particular branch, or merge that file, so you can refer that file in your working area. So if I want to change the logout file, so first of all I need to pull the latest changes of logout file from the remote to my local repository and refer that file in your working area. Referring that file in working directory means, it just means that open that file and see any merge conflict are there or no. If merge conflict are there, then you use this git merge, or you can directly pull that file. It will solve the merge problem. Yes, so I think if here you are not clear about the workflow, as we go in the slides, we will be using all these commands, so you will have a clear idea on how this will work. So here is a consolidated list in a diagram for the operations and commands of the Git. For the starting, first of operation we perform on the Git is creating a repository. The creating a repository, it means both. It will include both repositories, creating a local repository also on our workstation, and creating a remote repository. In our demo, it is a Bitbucket repository. So creating a repository, git init command is here. So it will just create a repository on your local area. So after that, making changes. So when we create a repository, so we will add a file, or we can it is but obvious that we create a file, we done our coding in that, and then after that we can check the status, we can add that file as we saw in the last previous slide, that after adding it will commit it to the staging area, after committing it will go to the local repository. So these are the files we these are the commands we will be using in the changing changing the files or committing the files. So in the parallel development it will include branch, merge and rebase. It is so it will be covered in the slides. So uh, syncing the repositories is a part when we create a repository in the local using the git init. So we need to sync that with our remote repository. As here we can see it this. The local repository is in sync with the remote repository to do the push and pull operations. So for that sync we need to sync our repository, local repository, with the remote repository. So these are the commands to sync with the remote repository. After that, creating a repository. So just I say it will include two options: creating a repository in Bitbucket, which we can say it is a remote repository, and creating a Git repository, it is a local repository, which we refer locally on our machine. So I will show you how to create a repository locally. Afterwards, I will show you how to create a Bitbucket repository. So we will go to our required folders. As we can see, here are no files, so we can quickly create a folder. So project code, here are no files in project code. Yes. So this command is used to create a local repository. So what will this do? We will check git init. So this gives a message like initialized empty git repository in this location, and this is our folder or the .git folder, which includes all your details of created objects, commits, commit ID, commit changes, versions, branches, merge, everything. This folder is very important, which will be created here. Sorry. Oh, yes. So it will show you this is a hidden folder because it includes a dot at the starting. So it will be we can go into that. Yes, one sec. I will clear the screen and show you. Yes, as I said, it includes the objects, it includes the branches configuration, it includes the configuration of our local repository, it includes metadata, it includes the reference for that committed IDs. Okay, So we have successfully created the local repository in our system. So clone git clone command is used when we suppose we have created a remote repository in Bitbucket, and we want the code which is on the Bitbucket, we want that code to our local repository. So we just need to clone that code. I will show you that in the next session when we create a Bitbucket repository. So without having a Bitbucket repository, we can't clone, or without having any remote repository, we can't clone the changes, or we can't clone the code from remote to local. So we will be doing all operations regarding the local repository in this session. In next session, I will be covering how to do operations with respect to remote repository. Okay, so this first part and the last part will be covered in the next session. Okay, so yes, this syncing with the repository is also a part which I will be covering in the next session, because in the next session we are creating a repository on the Bitbucket. So for now we don't have any repository on the Bitbucket or remote location, so we can't do these four operations, that is pull, push from the remote repository. So I will cover this slide also in the next session. So making changes to the local repository. So we will cover all these commands in our session. Okay. So first of all, we will check what is the status of my local repository now using the git status command. On branch master, as you can say here, on the on branch master, no commits yet because we have not done anything. This is a fresh from scratch local repository, nothing to commit because we have not done anything to this local repository, so nothing to commit. Okay, got it? Yes. So first we will create a file. As this is a Linux machine, so vi editor is there, so you can create using vi, and in Windows you can normally create a file and edit that. So I can write that first.txt. So write something, first file of code. Okay, save by wq. Yes. So we will get this file first. So the text is their first file of code. So we will again hit the command git status. The previous message was nothing to commit, but here this is the just created file is in the untracked file. Okay, so as it is saying we are on the master branch. So just to brief about the branching, master branch is the by default branch when we create a repository. So as and when required, we can create branches in one repository. So we will see that in detail afterwards. But just to brief out, master is a by default branch, and we are on the currently we are on the master branch. So all changes and all commits are on the master branch. Okay. So as this is saying, this first.txt is untracked file. So what he is suggesting, do the git add and file name. So we can refer the PPT as it is saying that git add and file name. this will add your file to the index, that is the staging area. This just add your file to the staging area. So git add and the file name. Okay. Again, we can see a git status. What they say, firstly this was in the red, now this is in the green. How? Because we have done the git add. So git add is nothing but it added the first.txt to the staging area. Okay. So changes to be committed. So we can now commit our changes. So this is a commit command we use for the git is git commit hyphen m and in double quotes give the commit message. What does this commit message do? It is used to refer our commit, and we can clearly identify our commit by using the commit message. And it is a must and it is not optional, it is mandatory to give a commit message. So get commit hyphen m and then message, we can say the first file committed. Okay, what this shows, one file changed, one insertion, and what is this? This is the commit ID it is giving, and we can refer the our commit first file committed to commit with this ID. So we can check a log. Yes. So here it shows you all the logs of the commits and uh, changes of the local repository using the git log command. So as I said, this is the ID, first digit of the ID we refer for our commit. So, and this is the commit message. As we can see, this is the master branch and we have committed to the master branch. Here you can see the use of our configured username and email ID. So if we have not configured username and email ID, this will not be identified who have done this commit. If we not give the commit message, we can't describe for what purpose this commit was done. But 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 that commit is not optional, so you must have to give that commit message. Okay. So I think all of you got the idea about how to create a file, how to check the status of file, how to add the file to the staging area, and how to commit that file to the local area. And if required, how to see the logs of your commit in the local repository. Okay. So yes, before going to the branching, I just want to show you, as I have shown you how to add a one file with the command git add file name. If I have a multiple files, just here is a one file. If I have created another file, second.txt. Yes, so second file of code. Save this file again. and I have again changed some part in my first file edited. Okay, so I have created one more file and edited the first.txt. So check the status. Yes, it is saying one file is untracked and one file is modified. So how to add this file? You can just, rather than adding one file, we can just say add dot. Dot means add all files, or you want to add a specific files, then you can just write first, second with the space list. You can write the space list of the files with the space. Yes, so we have added multiple files with the dot, git add and space and then dot. Again we can check the status. Okay, two files are in green, so we just need to commit that, -m and then commit. Second file added and first is modified. Okay, two files are changed, three insertions are there, and this is, as I say, this is a commit ID. Okay, this is my commit message. So we can quickly check the logs, get logs. So you can see the second commit message also. This is done by Deepika Joshi, email ID is this, and the commit message is this. Okay, so yes, we can now learn about the Git branching. So as you can see, Git log, there are two commits, okay, and both are in the master branch. So what the branching is, we can simply say the branching or the branches are the pointers to the specific commit. So as the diagram says, you can visualize this. I have committed one. C1 is my first commit. After that I have committed this C2, and this refer to the my master branch. Okay, I was in the master branch because master star is given to the master. Again I have created a new branch. So the changes C2, it refers to the master branch, and after that I have, suppose I have again committed the changes and that I have done in the new branch. So I am currently into the new branch and I have committed this. So new branch is pointing to the latest commit, that is C3. So simply it is a pointer to the specific commit. So there are two types of branches, that is local branch and remote branch. So as there are two types of repositories, one is local repository, another is remote repository. So the branches of the local repository are local branches and the branches of the remote repository are the remote branches. So we can quickly look at the how to create branch. Okay, so first of all we will see the branch list in our system or in the local repository. So just do git branch. It will show you the list of branches in your local repository. So it is master branch. Currently we are only having the master branch. Okay, and star means here The star means we are at the master branch. Okay, so we can just create another branch, git branch, and then give the branch name, which is first branch. Okay, so again we will see the list of branch. Yes, so it is showing two branches currently, the first branch and the master, but we are currently to the master branch because star is there. So if and currently we are in the master branch, so check the files in the master branch. So if I want to go to the first branch which we have just created, so just do check out and the branch name. Switching to the branch, first branch, do the ll. Yes, the two files which we are having in the master branch are here because when we create any branch, it is a copy of master branch because we are creating that branch from the master branch. Okay, so we see Git branch. So it is green and having a star at the first, so we are in the first branch. So this is a command we have covered: git branch to create a branch, git checkout to switch to the specific branch, git branch which give you the list of all branches, and then so here are the two files. Suppose I am a developer one, and I want to I have assigned issue one, which is something like any functionality, and I want to do the code changes or adding files and committing that changes to the local repository and after that remote repository. So what I will be doing firstly, that we all know, create a file which is having our code. So create a file. We can say the third.txt. Yes. So insert a code. This is third file of code. Okay. So yes, this is the third file I have created. So there are total three files. Again, check the status. It will show the third file is not added or committed to the local repository. As we know, add the third file to the staging area. Again, commit that third file created to the local repository. Yes, one file is added, third file is committed to the local area. So we can just quickly check the log. Yes, so you can see the difference here. This and this is the master branch commit, and the latest commit which we have done is in the first branch. Okay, so there are the three files. So one more thing, as we firstly check out that if I create a new branch and check out the code, all code from the master branch is inherited to the newly created branch. But is this a vice versa happens? So we will check that. What is the command for checking out to the another branch is git check out and the branch name, which is master. Okay. Oh, sorry. Spelling mistake. Yes. Switch to the master branch. We can quickly check on which branch we are. We are on the master branch. Yes. We can check the. Oh, what is this? So, third.txt is not present in the master branch. Why so? Because the first branch which we have created was inherited from the master branch, but the changes are committed to the master branch. Changes are committed to the master branch are not which we have done in the first branch are not committed to the master branch because it is a opposite direction. So this is all about the branching strategy or branching structure in the Git. It is a merge. So after that, after branching, we will go to the merging. So it is a way to combine work of different branches together. What does this mean? As we see, the changes committed to the first branch are not committed to the master branch because it is a opposite way. But if we have a production release or we are releasing that feature, so we must have the all latest commits or all latest code from various branches to the master branch, because we generally refer master branch for the production release or releasing any feature. So so this is this option or this we can say the command or operation give you the facility to merge your latest changes from another branch to the master branch. Okay. So so uh, so the syntax is, or the command is, git merge and the source branch name. In our case, okay, so first we will go through this diagram. As here, C1 is the first commit. After that, developer committed C2, then C3, then C4. But here, the C4 is referring to the master branch and C3 referring to the new branch. In our case, it new branch is the first branch. Okay. So how we can merge or combine the changes from C3 to C4, because master branch will be referring finally for the release. So after git merge, what happens is, you can see here, C3 refers to the new branch, C4 refers to the master branch, and we want to merge the new branch code to the master branch, then we can do the merge. So this is the command git merge and source branch name. Source branch name is here in this case is new branch. So git merge new branch. But keep in keep this in mind, we are adding or merging the changes to the master branch, so we must, our cursor or pointer must be in the master branch. So let us check. So as we can see, the two files are there. Where we are currently is the git branch. Again the spelling mistake. Yes. So we are currently at the master branch, and as I said, we are committing or merging our changes from first branch to the master branch. So our cursor or pointer must be in the master branch. So this is right, we are at the master branch. So merge, merge the changes of first branch to the master branch. Updating. Yes, it is showing updating third.txt is added. This plus sign shows you that this is added, one file changed, one insertion. Okay, quickly check the code files. Yes, this is present in the master branch. Third commit. Okay, third txt. Clear, just quickly check the log. Okay, so as you can see, this commit was firstly in only the first branch, so this is also refers to the master branch. Okay, so as we can see, the all files are here, and this is the way if you have committed or done the uh, code changes or the feature and feature code in one branch and you want to merge that branch to the master branch, so you can just do the merge command and check the logs if that is correct or not. So this is used, and after that so suppose uh, I have so these three files are here present in the master branch, so I don't no more needed. The branch which I have created is first branch, so you can delete it further after your release is complete and that functionality is working properly, because once you delete you can recover it using a command, but for the safer side, after that functionality is working properly, you can delete that branch. Okay. Yeah, just we covered the merging. After that, the rebasing. Okay. What is the rebasing? Sorry. Yeah, what is the rebasing? So this is another way of the merging code from another branch to the master branch, or we can say the combining work from the different branches. So as you can see in the merge, what happens is, here you can see this is the result after merge command. This is simply like the creating another commit of the these two commits and referring to the latest commit with the master branch. So what here is, with the rebase, what you can achieve is the linear sequence or the linear commits of your previous commits. So here is no any extra commit, that is C5. No, in merge you can see the C5 is there, but in rebasing C5 is not there because no extra commit is there, it just refer to this. Okay, it just refer to this. C3 master branch, C4 new branch, and then here also C3 master branch, and after rebase, same way you can do the rebase using git rebase and source branch name, that is the new branch here, and after that you will be seeing your all code into the master branch. Okay, so you can use rebasing for two purpose, like clean history of the commits, like no mess or no chaos of the commits, like here are very we can say non-linear structure of commits, but using rebasing you can achieve a linear way or linear sequence of commits, and you can have a clear history of commits, and the same way as in the merge, you can clear or you can delete a branch afterwards. Okay, after merging to the master branch. Yes. So that's all, and we have covered the all required commands and the concepts from Git. So to quickly check with, yes, so you have a clear idea for this workflow. So I will just quickly brief on this. So as we go through from the command, so you can quickly connect to this. So working directory. So I have created a file. I have changed that file. I have added the code that refers to the working directory. So after I do the git add, it will refer to the staging area, and after I do the git commit, it will refer to the local repository. And after that, git push and pull, we will cover it in the next session. So I think you all got these 3 points which refer to the local repository. So that's it, guys, and I think you got a clear idea, or we have covered everything regarding the Git, which is commonly used in a project. So you can use Git for the version control in your coding. And best of luck and use a Git. Yeah, thank you.